Ever wondered how drones can turn regular photos into a full 3D world made of millions of tiny dots? That's what we call a point cloud. And today, in 6 minutes, we're giving you a quick look at exactly what it is. And see for yourself what a 200 plus hectares point cloud dataset may look like. Let's start with the basics. A point cloud is simply a huge collection of points in space. Each point has a position, an X, Y, and Z coordinate. When you combine millions, or sometimes billions, of these points, they form a detailed 3D model of the environment. Think of it like standing back from a painting. Up close, you can see every dot of paint. But once you step back, all those dots merge into a complete picture. A point cloud works the same way. Each point by itself doesn't mean much, but together they form a realistic 3D reconstruction of the real world. These points represent the shapes and surfaces of everything in the area: the terrain, buildings, vegetation, rivers, roads. Everything that the drone captured from above. Now, here's the cool part. All of this is generated from photos, not lasers, just regular images captured by a drone. For this point cloud dataset, we used the DJI Mavic 3 Enterprise, which flew multiple mapping missions over an area of more than 200 hectares. During the flights, the drone captured over 4,000 images with consistent overlap. These overlapping images give the software enough visual information to calculate depth, shape, and position. Every photo contains details, textures, edges, patterns, and the computer matches these features across multiple images. When the software recognizes the same object from different angles, it can triangulate its 3D position. That's how we go from simple 2D photos to a full 3D point cloud. Once all the images are captured, they're imported into Pix4D Mapper, a photogrammetry software that specializes in reconstructing 3D models from photographs. The software goes through a few key steps. First, it aligns the images and identifies matching points between them. This forms what's called a sparse point cloud, basically the initial framework of the 3D model. Then, Pix4D densifies the point cloud. Using advanced photogrammetry algorithms, it adds millions of additional points, filling in details and forming the complete, dense point cloud you're seeing right now. The result is a realistic 3D dataset that can be used for mapping, analysis, engineering, construction planning, environmental monitoring, and much more. So why do we use point clouds? Because they give us a highly accurate, measurable representation of the world. From a point cloud, you can measure distances, heights, areas, and volumes. Extract terrain data, create 3D models of buildings, monitor changes over time, support design work in CAD and GIS software, generate contour maps, author mosaics, and digital elevation models. It's one of the most flexible and useful products you can create from drone photogrammetry. And unlike a simple photo or video, a point cloud lets you interact with the environment, rotate it, zoom in, inspect details, and even segment different features like ground or vegetation. To give you a sense of scale, the dataset you're seeing covers over 200 hectares. It was captured with 4,000 plus high-resolution images, all processed into millions of points. For a dataset this size, the processing requires a reasonably strong computer, the kind of hardware setup that ensures smooth processing, fewer crashes, and faster generation of the dense point cloud. So that's what a point cloud is, a detailed 3D snapshot of the world, created from nothing more than drone photos and smart software. Now, as the animation continues, you'll be able to see the depth, structure, and detail inside this dataset. Every dot you're looking at represents a real point on the ground, captured by the DJI Mavic 3 Enterprise and reconstructed in Pix4D Mapper. If you'd like to learn how to capture or process point clouds yourself, or want more about drone workflows and datasets like this, make sure to subscribe and feel free to drop a comment. Thanks for watching, and we'll see you on the next one.